Hi, this is Michael Leonard, the TA for C100 and C200. We went over the programming exercise and discussion, but I thought it'd be good to actually step through and actually see what's going on when you're typing it into the terminal line by line. Okay, so let's get started. First things first, you want to power up your virtual machine. You can do that by opening VirtualBox and either double-clicking on your virtual machine or pressing Start. And so while that's going, I'll get on with the rest of this. So in class, we already covered that computers only really know what to do if you tell them what to do. And the process of telling them what to do is called programming. So with computers, you have to be very specific in what you tell it, or else it's not going to know what to do. Every word is important. The order of every word is important, and sometimes even the spacing between words can be important. So the computer is very strict to that. It only knows what to do if you tell it what to do. It's kind of like teaching a 10-year-old how to make eggs Benedict. And so if you're in class, you saw this example. If the program worked, if you told the computer or 10-year-old exactly what to do, your program also works, and you get eggs Benedict. If you were unclear on any part, it's probably going to crash and look like that. Okay, so again, we'll be using the Python programming language. It's useful because in bioinformatics, people actually use this language. It's a good introductory language because it reads pretty close to English, and it doesn't really matter too much what's going on behind the scenes when you're thinking about Python. It's really straightforward for a beginner's point of view. One of the problems is that it's almost too simplistic at times, where the white space that you're typing in, sometimes that matters also. So the difference between tabs or spaces, sometimes you have to watch out for little things like that. But for the most part, it's pretty straightforward. So like I said, in class we went through this on the board, but today I'm going to go through the terminal and actually type in all these things and tell you what's going on line by line, just so you really get a feeling for the fact that programming is only what the computer sees, and it only knows what to do if you tell it what to do. So to get started for this and for any homework assignment, we're going to open the virtual machine, which we already did. That should be on the right side of my screen. We're going to get to the terminal by pressing the menu. That's kind of like the start menu in Windows. And we're going to click Terminal from the Systems portion. Okay, I'm going to make mine big just so you can see it. Okay, so that takes care of step number 1 on this slide, and 2. Now, to get into Python, it's pretty simple. We just type the word Python. This is called the Python interpreter, where you run code as you type it in, and you type it in one line at a time, and it gets executed pretty much one line at a time. So now that everyone has their terminal open and they're in the Python interpreter, we can actually start going through the portion of code that I showed in class. Just one note, this is a little bit different from what we showed in class. I'm going to talk about a couple more things, but nothing too hard. Okay, so the first line, the first thing we see at all, is the line that says import sys. So what is this doing? The idea behind that is that in programming, you don't want to be reinventing the wheel every time you're writing a program. In school, we're told not to copy other people's work and not to plagiarize, but in programming, it's encouraged to use other people's work because that means you're spending time on problems that are new and not problems that have already been solved. So the way that people distribute code to other people are in the form of these libraries. And one of them that's actually distributed by the Python people is the system library. So the line reads out import sys, which is shorthand for system, and all that's doing is importing the system library. Yes. So if you wanted to use code from other people, you can either paste it into your program usually at the beginning, or you could import a library, which is much more succinct, and you don't really have to worry about what you're importing. You kind of just assume that they've taken care of it to the point where you know it's going to work the way they say it work. So in class, I mentioned libraries, and we went over it a little bit, but we didn't actually use a concrete example. In this exercise on line 8, or line 9, we're going to be using the system library to output some text. The system library itself is it's really useful for importing or outputting text into the program. You can also output text to files and all sorts of things with it, but for now we're going to keep it simple. So that's line 1, just getting everything set up for the actual program that we're going to write. Line 2, this is also new from class. This is a comment. Comments are usually denoted by this pound or hashtag character. They're useful for people that have to read the code. They're not useful at all for the computer. In fact, the computer is going to skip over anything in a comment. So let's start typing stuff in to show you what I mean. First, we import the system library. Nothing should happen because it's only doing stuff in the background. We're not actually starting our program yet. So the first line of our program says, give them an introduction message. So instead of doing it, the Python interpreter completely ignored that this is an instruction. And instead of these 3 kind of greater than signs, which means type in the next command, we got 3 dots, which means the Python interpreter thinks you're not done with the line yet. So that's implying that the Python interpreter completely ignored what you told it to do, and now it wants you to do something else so that it actually has something to do. Yep. And just a note, comments typically talk about the code on the next line or the next couple lines. So this one said give them an introduction message, and then on line 3, we're going to output a message that says welcome to Chem C100. Comments are really just for the clarity of reading the programs. The computer ignores them completely. So, like I said, in line 3, we're going to print the message welcome to Chem C100. Like I mentioned in class, printing means printing to the screen. It doesn't mean printing to a piece of paper or a printer. So print tells Python to output the text onto the screen. Specifically, in this example, we're going to output the text, welcome to Chem C100. So in the interpreter, since Python is still waiting for us to actually type something that it can use, we're going to type in print, welcome to Chem C100. Now that we do that, it outputted 1 line of text, exactly what we told it to do, and it also gave us the greater than signs back, which means that now it's ready to do another line of code. Okay, so that brings us to line number 4. On this line, we already know how to print to the screen. The only novel thing is that now we're going to be printing with a function. So functions are typically words with parentheses after them, and there's usually something in the parentheses. And what this is telling Python to do is that you're going to run another piece of code behind the scenes. And these can either come from something that you write, or they're typically involved in these libraries that you import. So Python, in this line, you're telling it to print the range, and it's implied from 0 to the number 5. So the function, instead of printing 5 separate lines that says print 0, print 1, print 2, print 3, print 4, now we're using a function that just returns a 0, a 1, a 2, a 3, and a 4. So again, functions kind of reduce clutter, they increase readability, and they make it so you don't have to paste the same thing into your code multiple times. They're a way to kind of simplify your code. So the function range returns a list of numbers from 0 up until the number before what you said, because it started with 0. So this is give us 5 numbers, and it gives us 0, 1, 2, 3, 4, It does not include the number that you gave it because it starts at 0. One thing to note, and we'll be talking about it again over and over again, but computers don't start counting at the number 1. Computers like to count at the number 0. And so sometimes it gets a little bit confusing, but usually it's because you started counting from the number 0. Okay. I showed you what should be the output in this slide, but we can actually go through now and type this in just to see what we get. So we type in print, which we know is going to output a message, and then we want to print the range function from 0 to 5. So when I press enter, it returns 5 numbers from 0, and then the last one is 4. But if you count them, that's 0, or 1, 2, 3, 4, 5. You gave 5 numbers in order. And that's all the range function does. This brings us next to our 5th line, line number 5. This line is going to introduce the concept of a variable. So just by the name, the word variable means that something can change. And if we didn't have variables, we would have to explicitly say that we're looking for, in this case, we want to call a student the name Michael. So we're saying we have a student named Michael. Variables can hold numbers, they can hold letters, they can hold words, they can hold pretty much anything. They're the building blocks behind programming because they allow for things to change and for interesting things to happen when you're programming. So just to see what I mean, I'm going to type in the line of code on line 5, a student equals Michael. So now I'm saying that this variable is the name Michael. Because it's a variable, we can change the name. Now we're saying a student, we can say his name Jeff. And if we print what the name of the student is, a student, now it could be called Jeff. So it's variables are supposed to be able to change, and you can pretty much make them whatever you want. And Python pretty much takes care of all the hard stuff for you. So just to clarify, variables are things that you store numbers, letters, or names in. In this case, we originally assigned the name Michael to a variable called a student. And for instance, we could use that later to say what's the grade of the student, what's the last name of the student, what's the social security number of a student. And in this case, we'd be interested in a student named Michael. But say next time we do this, we want to look at a student named Jeff. So we can also assign the name Jeff to the variable a student. And assignment is usually done with an equal sign. So to read this, you would say, we're assigning a student, which is a variable, the name Jeff, or the name Michael. And it can change. All right. And again, we can print, which means to output the name of a student, and it gave us Jeff, because that was the last name we gave it. Okay, this brings us to line number 6. Again, we're assigning a variable. The variable we're assigning is named list of students. And what's different in this line is we're introducing the concept of a list. So a list is a series of numbers or text or letters. In the series, each element of the series is given a number. It could be the 0th element, the first element, the second element. And the number that you assign it is called the index. So the index is saying, I want to give the first or second or third element. So the example is the 0th element, because computers start with the number 0, is given the name Seinfeld. The first element is given the name Kramer. The second element is given the name George. And one thing to keep in mind is that the order that you give it for a list is the same exact order that you're going to get every time. So if you say, give me element number 0, it's going to give you the name Seinfeld of this list. So one thing to note, that in the line number 4, 2 slides ago, when we typed in range from 0 to 5, it actually outputted a list. So that's over here. It gave you a list starting with 0, and then 1, and then 2, and then 3, and then 4. So now that should clear up kind of the idea of a list or a variable or functions, and hopefully seeing it kind of puts it into a little bit more perspective. So again, we can say a list of students is equal to Seinfeld, Kramer, and George. So in English, you put commas inside parentheses because that's just proper grammar. But in programming, proper grammar is anytime you want to make a name or a list of words or something, you put it in quotes, and that tells the Python that this is one block of names or numbers, or when you use quotes, it's going to just be what they call a string of text. So a string can be one word, a string can be multiple words, it could have spaces in it, it can even have new lines in it, it can do a lot of things. But just for clarity, we're putting one word per each string, and the string is the name of a student, and there's a list of multiple students. So the first element of our list is the string Seinfeld, and a comma separates elements of list, and then the second element of the list, which has index of number 1 because we started counting from 0, is Kramer, and then the element with the index of number 2, which we're calling the third element of the list in English, is George. So all these are in quotes because they're separate strings. All of these are separated by commas because they're separate elements of the list. And when we press enter, it's not going to output anything because we didn't ask it to print anything in this. We only assigned this list to the variable list of students. That's going to bring us to line number 7. And again, I'm really pounding in the idea that computers just count from the number 0. That's all this line is saying. So in this line, we want to print the list of students. And let's say we want to look at the first element, or element number 0. Oh, actually, we look at the second element, which is element number 1. So reading this, you would think it says print out the list of students and give me the first student. But since they count from 0, it actually outputs the name Kramer. Okay. So in this case, I don't know if you noticed, I've misspelled a couple things so far. Up here, I misspelled my own name. I put it Michahel. That's not how you spell my name. But here, I misspelled the word list of students, and I typed in students, which is STDUENTS. And that gave an error because now we tried to access a variable by a different name. So I'll talk about debugging in a little bit, but right now I'm just going to tell you that the problem is that I misspelled the word students. So let's spell it correctly. And I say the list of students is Seinfeld, Kramer, and George. It doesn't return anything because we're just assigning a variable. And if I want to print the list of students, spelled correctly this time, and giving me the student with the index of 1, we'll see instead of printing Seinfeld, who is in English the first student, it's going to actually give us Kramer, who is the second student in English, but has the index of number 1, because we have Seinfeld with an index of 0, Kramer with an index of 1, and George with an index of 2. So we say print the list of students that has an index of 1, and that's Kramer. Anytime you see the square brackets after a list or a dictionary, that means you're trying to get a subset of that list or dictionary. We'll talk about dictionaries in just a second. But you can get a range of students, or you can get just one. So in this case, we just wanted student with the element number 1 in the list of students. Okay, that brings us to line number 8. So I mentioned another concept called dictionaries in the last slide. Dictionaries are very similar to the idea of a list, except for in a list, we give it a number per the element. So Seinfeld is student number 0, Kramer's student number 1, George's student number 2. In this case, we're going to give it a name for each student. And so the order of a name doesn't really get saved in the computer too much. So here I say dictionaries do not keep track of the order of elements. However, a list does. So if you ask for the first student in a dictionary, it might give you Seinfeld, but it could give you anything just based on how computers store it. So the question is, how do you access, in this case, we give them the grades per each student. How would you access the grades of a student that you're interested in? Well, it's pretty simple. Just like with a list, we asked for the number of the student. Here, we can ask for the name of a student. So before we get ahead of ourselves, let's type out this line. Student, make sure to spell it correctly, which I did. Student grades equals Seinfeld, who gets an A, let's just say. Kramer, who gets a C, let's just say, and George, who gets a B. Notice that it went on to the next line just because I'm zoomed out a little bit, but that's okay. All right, so just to read this out, we say we have a dictionary of student grades. We're assigning that the value that Seinfeld gets an A, Kramer gets a C, and George gets a B. So again, because we're assigning something, Python doesn't output anything to the screen. And so instead of saying Seinfeld is student number 0, now the order doesn't matter. Seinfeld could have been last, he could have been first, he could have been in the middle, but every time you ask for Seinfeld, you know that he has an A in the class. So we'll access this dictionary in a second, but because last time I didn't talk about libraries too much, I want to kind of go into the system library just a little bit. But to reiterate, lists and dictionaries behave very similarly. The difference is that for a list, you give it a number, and for a dictionary, you give it a name per each element. Okay, so bringing us to line number 9, we see something funky that we haven't seen before. We know that this is a function, system.standardout.write, parentheses, George got this grade, colon, space, and then that's the text that we're going to output. So just for the example of this exercise, we could have done this with the print command, but I want to give you another way that the system library can output text to your screen. So the system library has a function called standardout.write, and you put the text that you want to be written. This is kind of similar to the print function that we've been using, but specifically when you output with print, it goes to the next line automatically. But with standardout.write, it does not go to the next line automatically. And we'll see that in just a second. One thing to note, because this is part of the system library that we imported in line number 1, we have to tell it where to find the standardout.write function. So if you just type standardout.write, Python wouldn't know where to look. So you have to tell it it's in the system library, and you type a period, which tells it you're going to use something from the system library. And then you tell it systemout.write, and you're going to give it text to write to the screen. So again, the first part of this sys is the library it's coming from, and the second half, standardout.write, is the function you're actually calling. Okay, so let's see it in action. The difference between print and standardout.write is that standardout.write does not automatically go to the next line. It's going to look a little weird in the interpreter, but at the end of this video, I'll run this program completely at one time, and it'll make a lot more sense. But for now, let's type out line number line like we would in the homework assignment. So we say sys.standardout.write, which is a function from the system library, and we're telling them George got this grade. So when it prints, you would assume that it prints this text, George got this grade, and then goes to the next line. But because we're using the system library, and specifically the standard out.write function, it's going to output the line of text, but not go to the next line. So this looks a little funny in the interpreter. It prints the text, George got this grade, and then a colon, and then it gives you the 3 greater than signs, which means type in another line. So it didn't go to the next line automatically. Now we're all typing within the line that has George got this grade. This would be pretty useful for programming, as we'll see later, but when you're typing it line by line, it doesn't really add too much when you're thinking, should I use print or should I use this standard out? Okay, but again, I'll go back to that in a couple more slides. In line number 10, now we said we're going to tell you what grade George got. Now let's actually print which grade George got. So again, with lists or with dictionaries, the square brackets tell you, I want to access something within this list, a subset of this list. So for now, we're going to say print the student grade of George. So a subset, and it says George. Okay. So again, it's on the same line as the text that we outputted last time because we never told it to go to a new line. And we want to print on the next line the grade of George. I'm having real trouble spelling today, so print, again, if we spell it the right way, we can see that George got a B in the class because we assigned B to George when we were assigning this dictionary. We'll go over this again in a couple slides just to see what I mean with the new line or not going to the next line. But for now, we said that George was going to get a certain grade, and he got a B. So this is really just to show how to access a dictionary, which is slightly different from accessing a list, but not too different. There's still square brackets, and we still gave it, when you work with dictionaries, you call them keys, and when you work with lists, you call them indexes. But you pretty much say, I want this element, and it gives you the value of that element. Okay. The thing about programming is you don't want to do just one thing at a time. Usually you want to look over your entire list of students or your entire list of genes or whatever you're really programming at the time. So programming is all about automation. You really want to do everything at one time. To do this, there's the idea of a loop. There's different types of loops, but just like you would expect, you kind of loop over the same bit of code over and over again. So let's just type out this line and read what it means. So I say the list of grades is now equal to, I'm assigning a variable called list of grades. We want to use a loop, so we say give me the student grades, hopefully I spelled it right that time, for the current student in the list of students. So again, let's assign the variable list of grades with the grade of the student for every student in the list of grades. So that's going to go through up here. We can see Seinfeld will be first, Kramer will be second, and George will be third. Because when you loop through a list, you go in the same order of the list because lists have order. So let's see what it says. It didn't give us any output because, again, we're just assigning a variable. And if we do want to see what this list is, if we did it correctly, it'll give us the grades of each student in the order that the students were given. So we can say Seinfeld got an A, which we see here, Kramer got a C, which is the second element of the list, and George got a B, which is the third element of the list. So the grades got outputted in the same order that the students are in. Okay, so this is fine. We used a loop to automate getting the grade for every student. One more thing about functions is there's a ton of them in Python. We can go to line number 13, and there's functions for lists, there's functions for strings, there's functions for everything pretty much. Anything you'd want to pretty much do that's not too complicated, there's probably a function for already somewhere in some sort of library. So let's say I wanted these grades in alphabetical order. We can use the sort function that Python provides, and we can just sort the list of grades. So let's do it. List of grades dot sort, and again it's a function, so we use parentheses. And so when I do this, it's only sorting the list of grades. It's not going to output anything, but as we know, we can print to the screen the list of grades, and now it gives you the grades in alphabetical order. We don't know who got whose grade now because it's sorted. Now this list is out of order, but somebody got an A, somebody got a B, and somebody got a C. So now that we've done all this, that pretty much covers everything that's the basics of programming, pretty much. We learned that the interpreter reads it line by line, the computer's going to read it line by line, and now we know what a lot of these things do. So that's it. That's basic programming. Congrats, you're now a programmer. One thing I want to show you is that typically scientists or engineers, they're not going to be typing out the program every time they're trying to run it. That'd be ridiculous. That'd be like if every time you start up your computer, you have to type out exactly what the computer's going to do. Instead, most of the time programmers save everything in a text document, and then you run it all at the same time. So like I said, code is usually written to a file or a document and then run all at the same time. When you do that, you don't see any of the text that's inputted. You only see the output by the print statements. So what I'm going to do now is I'm going to exit the Python interpreter by typing the function exit. That quits. Now we're back to our Linux terminal. Linux is the operating system we're using here. And you can type the word ls and press enter, and that tells you everything that's in your current folder that you're in. So the default folder is this little tilde, and I created a file called example.py. So what's in this file, if we look at it, you can output the text in text files by the word cat, and then a space, and then the name of the file. But I'm going to output everything in the example Python script. It's almost exactly what we listed on the slides. The first line's a little different because we have to tell it you're going to use Python in the first place. But just to confirm, this is everything that we typed in the slides. So when I run this program, the example Python program, it's going to only give us the print statements and nothing else. So remembers from slides number 9 and 10, or lines number 9 and 10, the difference between print and standard out.write is that standard out.write does not go to the next line automatically. So what's this going to look like? We can run the script, Python example.py, and when I run it, it's going to give us, the first line said welcome to Chem C100, and then we printed the range from 0 to 5, which doesn't include 5. We got the second student in the list, which is Kramer, and then you get to this line. So with standard out.write, we said George got this grade, colon, and then we went to the next line of code. But since it didn't go to the next line, we can actually make things that look pretty good stylistically. So with 2 lines of code, we can output 1 line of text, which says George got this grade, and he got a B. The code would probably get really messy if you try to do everything at the same time. So you can split it up into smaller chunks, and it still looks the same to the user, so they don't actually have to know what's going on in the background. And then we printed everybody's grade, and we printed everybody's grade in alphabetical order. And yeah, that concludes everything we did for programming. Again, if you have questions, if anything was unclear, please come to my office hours or go to discussion, or even on the discussion forum on CCLE. You can post questions so that everybody can see them. Okay, that concludes the basic programming tutorial. I'll see you in class. Bye.